Algebra. Mr. Lawrence here with your flipped lesson. This is for the weekend of May 11th. We are almost done, guys, almost done. We got our chapter test on Thursday. That will actually close the grade book for the class because we'll be going to DC the following week. And then we come back, we'll have a couple days to review for the final. So the grade book is closing quickly. So if you have a test or something you owe me, you need to get that taken care of. All right. So we are going to start with domain and range. And domain and range should be much simpler now that you understand about restrictions. Because I think you get the restrictions pretty well. And I know when we did domain and range earlier in the year, you were a little bit confused. But now that you understand restrictions and your understanding of fractions has grown, this should be a simpler concept for you. So let me point this out to you first of all. There's the equation, right? Y equals 1 over x minus 3 plus 4. Now I'm sure some of you right off the bat, you know the restrictions. You know that you're going to get an asymptote at x equal 3, because x is not allowed to be 3. You need an asymptote there. And then you're going to get an asymptote for y is 4. All right. Now, just in case you need a picture, I've got it graphed right here, I believe. There it is. And you see, sure enough, here is the place where x is 3. And then if you look here, here's x, y is 4. And you get these asymptotes going on, right? Okay. Now remember, domain is all the possible x values. Well, in this problem, since the the only restriction on x is 3, the only restriction on the domain is 3. So simply all that means is the domain, and there's lots of different ways to say this, all real numbers such that x does not equal 3. So you see that? The part of the domain that isn't allowed to be is the restriction. You just say it's all real numbers and you take the restrictions out. All right? The range, same thing. Range are your y values, right? Remember that? I know it's been a little while. The y values, you can get anything out for y except for 4. So, be all real numbers such that y does not equal 4. There's your domain and there's your range. Now you can use the graph to get them, but if you don't need the graph, you don't have to. I'll do the second one without getting the graph. Hopefully you realize that you should factor this denominator and get the quantity of x plus 3 and the quantity of x minus 3. All right? So, see if you can figure out the domain and the range. You can go ahead and pause the video. I'll put them up here in just a moment. Okay, without doing a graph, I notice that my denominator, x cannot be plus or minus 3. So my domain is going to be all real numbers such that x does not equal plus or minus 3. All right. The range, excuse me, the range. I know my only restriction for y is -2. So my range will be all real numbers such that y does not equal, and I think I said -2. Yeah, there we go. All right, now if you need a visual proof, you can always go ahead and graph that. I'll leave that for you to do. You can go to the Fun Math Graphing Calculator. And by the way, Mr. Morris, I noticed you said you were having a problem, like the picture wouldn't show up when you went to that site to graph. 2 ideas. Do a search under free graphing calculators online, go to a different one. Or I noticed that when mine was loading today, it's a Java, I don't know what to call it, not an add-on, but you know what I'm trying to say, an update, installation. You need Java. You can do a search under Java, and I'm sure it's a free download, and put that on, and then it should work as long as your computer can handle it. And Java is pretty common, so I wouldn't expect it to be a huge deal. All right. Go ahead and try the next one. You can pause the video when you're ready. We'll see if you can do it all on your own. Okay, if you're watching, first thing I'm going to do is I'm going to factor my denominator. I'm going to get x plus 2 as a quantity and x plus 3 as a quantity. So my equation is 1 over quantity of x plus 2 times quantity of x plus 3 plus 7. So I know my domain is the restrictions on x. So my domain can be any real number such that x does not equal -2 or -3. All right, the range will be all real numbers such that y does not equal 7. And there you go. It's that simple. All right, we're going to change gears here. We're going to talk about inverse variation. You may have remembered direct variation from a long time ago. Direct variation said that if x increased, y also increased. And it had a simple equation like y equals kx, which looks a lot like y equals mx plus b, only the b is 0, and k was like your slope. Okay, and for example, the faster you go, the more miles you cover when the time stays the same. If I drive 50 miles an hour in 1 hour, I go 50 miles. If I drive 75 miles an hour, a faster rate, I cover 75 miles. Okay, that's direct variation. Today we're doing inverse variation, and what happens there is x increases, y decreases. For example, the faster you go, the less time it takes to get there. If you drive 30 miles an hour and you go 30 miles, you'll get there in 1 hour. If I go 60 miles per hour and I go 30 miles, I'll get there in half an hour. Okay, so the faster you go, the slower or the less time it takes. That is inverse variation. Think about the bathtub. You're on you got a sore muscle. You want to sit in a really hot bath. You run a really hot bath, and you sit in there. You get in, and the longer you sit in there, the longer amount of time, what happens to the water? It begins to cool. Let's say you fall asleep in there, you wake up 2 hours later, it's the middle of January, and that really hot bathtub that you kind of had to creep into to get your muscles in, and it felt so good and so relaxing that you fell asleep, and you woke up 3 hours later, and now you feel like you're like a polar bear, those people who jump into the ice water in the middle of winter, because the water temperature has cooled way below your body temperature. So the longer you stayed in the tub, the cooler the water got. The time increased, the temperature went down. That is inverse variation. Now, you see this equation? You've got two choices. You can use xy equals k, which, remember, k is the constant of variation, or you can use y equals k over x. And all I did was take xy equal to k, decide to solve for x, and just said, hey, x and y are attached by multiplication. I'll undo that by division, divide both sides by x, and I get y equals k divided by x. They're the same equation. One is just manipulated to look different. All right, so let's say I'm told that x and y vary inversely, right? And I'll say x equals 10 when y equals 5. Find x when y, oops, I started to spell W-H-Y, excuse me, when y equals, say, let's make it 20. Okay, well, first thing I do is I go x, y equals k, and I plug in 10 times 5, and that's going to be my constant of variation, which is going to be 50. Then I take the same equation, meaning x, y equals k. But this time, see, this was step 1. There's step 2 right there. I don't know x. I know that y is 20, and I know k is 50. How do I know k is 50? Because I just solved for it. And now I get x to equal 50 over 20, which simplifies to 5 over 2, which could be said as 2.5. Now, if you think about this, this should make perfect sense. What happened to y? It got multiplied by 4. What happened to x? Well, it got divided by 4. Sure it did. If I cut 10 in half, I get 5. If I cut 5 in half, I get 2 and a half. So you see it's an inverse operation. It's inversely occurring. So if the one's being multiplied by a factor, the other one's being divided by that factor. In this case, by the constant of variation. All right, let's try one more, and then we'll call it for the weekend. So we know that x and y vary inversely. And I know that x equals, I don't know, 300 when y equals 600. Okay, I'm going to find y when x equals 400. Okay, and this one you might not be able to do in your head as well. Step 1, I'll write down the equation x, y equals k, and I'm going to use this data right here. So x is 300, y is 600, and I can solve for k. And so I'm going to get 18, 1, 2, 3, 4. All right, so k is going to equal 180,000. Now, think about this. Way back in September, October, when you guys weren't even a tenth of the math students you are now, and by the way, I am so proud of you, how much you've grown up. Really looking forward to DC. I'm looking forward to hearing from you when you come back from high school and tell me, how you get math now, because you're really doing a great job. Some of you have grown up so much. Daniela, Kaylee, Zach, and just a whole boatload of you. You're doing great work. I am really proud of you. Keep up the good work. All right, so step 2 is going to use the information from that part of the equation. So I'm going to use the same equation. Oops, x, y equals k. I know that x is 400. Y is what I'm trying to solve for. And then k is 180,000. 80,000. Well, it's a one-step equation. I'll divide by 400. Divide by 400. I'm wondering, let me know on Monday if you saw the screen just shake. Some kids were moving upstairs as I'm recording this. Those cancel. I get y equals, and I'm going to do some canceling here. And I'm going to get this over 4. And I don't like to divide by 4. I like to cut things in half and then cut them in half again. So I'm going to cut 1,800 in half and get 900, and cut that in half and get 450. And so there you go. That means y is 450 when x is 400. And that's it, as simple as that. All right, Mr. Lawrence signing off. Have a great weekend, everybody.